Artificial neural network. Artificial neural network is a mathematical model and core component in machine learning which mimics the working of the human brain or simulates the human brain learning process. In ANN, each neuron is considered as a node or a unit that acts as a computing node capable of processing a complex task. It is used for tasks like pattern recognition, classification, and regression. Fundamental role of any neuron is to receive, process, and transmit information. Now let's see how actually the biological neuron consists of, or what are the main components of a biological neuron. The biological neuron consists of four main parts. The first one it is called as dendrites. The second one it is the cell body. The third one is the axon, and the fourth one is the synapse. The dendrites they are present to receive the input to the neuron. Then the cell body it is going to process the information. Axon is the one that is going to transmits the output, and the synapse is the one that is going to connect to other neurons, because a human brain consists of millions on millions of neurons, and each neuron is capable of connecting to more than 10,000 other neurons, and a particular neuron can receive input not only from a single neuron but a multiple neuron. Finally, when you consider any neuron, it is used to process the information that is received as an output and gives the response. So, taking this into consideration, the artificial neural network has been mimicked, and we have a neuron or the artificial neurons, which are also called as nodes in artificial neural networks. Fine. So, in artificial neural network, as I told, each node is called as, or each neuron is called as a node. The node is used to receive one or more input and process it. Fine. If you want to look up, you can see there is an animation that shows how the biological neuron and the artificial neuron is considered. So here in the biological neuron, we have the inputs. That is not a single input, more than one input. We have the inputs that are processed, and finally the outputs are sent. In a similar way, the artificial neuron consists of more than one inputs, and we have a processing unit that is going to process these inputs, and finally it is going to give the output. So you can see in this diagram we have the dendrites that is considered, and in artificial neuron it is represented as an input where each input is are associated with the weights. Then we have the cell body, that is the processing unit. In a similar way, we have a model here or a mathematical method that is going to process these inputs along with the weights. And finally the axon, this is the one that is going to transform or transmits the output, and finally we are going to give the output. So this is how the biological neuron is different from the artificial neuron. So this artificial neuron is designed considering the working of the human brain neuron. Oh, we'll see what actually a simple model of artificial neuron looks like. The artificial neuron or a single neuron, it is designed by McCulloch and Pitts. So hence this model is called as McCulloch and Pitts neuron mathematical model, designed in the year that is 1943. Right? Now, whatever the mathematical model or a simple neuron we are going to consider, it includes two steps. It receives the weighted inputs from other neurons. So these are the inputs or the weighted inputs that are received from the other neurons, and it operates with the threshold function or the activation function. So it operates with the threshold function or the activation function. So so this is how the model looks like. If you consider the mathematical model of the neuron, so this is the mathematical model which is called as the McCulloch and Pitts neuron mathematical model. The neuron is a basic processing unit that receives the inputs and their associated weights. Fine. Finally, we are going to do the summation of these inputs along with the weights, and whatever the sum we are going to get, that is passed through the activation function, and finally we are going to get the output. So here so whenever we have certain input that has processed, if the input exceeds a threshold function, the neuron fires impulses through the synapses. It is nothing but this activation function is the one that is going to connect to the next neuron, and that is going to activate the next neuron. So that is where we have the activation function that is going to um, uh, map the input signals to the output signals. And this is the formula that we are going to find the sum, that is the net sum between the inputs and the weights. And we have the activation function. So the activation function is a binary step function that outputs 1 if the net sum is above the threshold value, and 0 if it is below the threshold value. So this is the activation function, wherein the input to the activation function is the weighted sum. And finally, the output of the neuron is y. So finally, we are going to get the output of the neuron, which is based on the activation function. As I told, this activation function, it is going to map the input to the output, or the input signals to the output signals. So we have 1, or the activation function throws the output as 1 if it is greater than or equal to the threshold value, and 0 if it is less than or less than the threshold value. So whatever the McCulloch and Pitts neuron model we considered, it can represent only Boolean functions. So if people are familiar with the Boolean functions, we have AND, OR, NAND, NOR, XOR, and so Boolean functions. A Boolean function has a binary input and provides a binary output. So this is a simple artificial neuron we have. With this, we take the artificial neural network structure. So as the name itself tells, it is not artificial single neuron. It is an artificial neural network. Fine. So if you consider the network structure of the artificial neural, fine. So this is how we can consider the network of the neural, or it can be called as the neural network, where basically, or typically, it consists of 3 layers. First one, we have the input layer, then the hidden layer, and followed by the output layer. Right. So first one, ANN structure, it is nothing but a directed graph with the neuron nodes. So these are all the neuron nodes and the weighted edges. As I told, the inputs, they're always associated with the weights. Even when I take your hidden layers, so we are getting the input for the hidden layers from this layer. So even these are associated with some weights. So we have 3 different types of layers: input, hidden, as well as the output layer, where this input layer, it receives the input. Then processing is done by the hidden layer. Neurons are computed, or neurons compute a weighted sum of inputs. The bias is added to the sum. Fine. The activation function is also applied to the sum. And finally, the neuron fires if the value exceeds the threshold or the activation level. And coming to the output layer, the output layer node produces a single output value. The core mechanism finally is what? The linear transformation. The linear transformation is what? The weighted sum plus the bias, followed by the non-linear activation, because we are sending this input to the activation function. The activation function is the one finally that throws the output. So this is the structure of the artificial neural network. Coming to the activation functions. So as I told previously, these activation functions are the one that is going to map the input signal to the output signals. So these are mathematical functions associated with each neuron. With each neuron, we have the activation functions. Fine. It decides whether to fire a neuron or not based on the input signals the neuron receives. It is nothing but whenever we need to normalize the values within a particular range, we can do it with the help of the function that are called as activation functions. So normally, the output value of each neuron that is sent as an input to the activation function, it is always either between 0 and 1, or between -1 and +1. Fine. Now, as we know, we have linear functions as well as non-linear functions. Fine. So typically, the activation functions used for linear, they are completely different for the non-linear function. Example for linear is identity function is used for the linear operations. Then sigmoid function, ReLU, tanh, and some other functions, they are used for non-linear functions. Fine. Now, the linear functions are useful when the input values can be classified into any one of the 2 groups, generally a 2-class problem. Find something like either yes or no, positive or negative. something like that. Nonlinear functions, on the other hand, are continuous functions that map the input in the range 0, 1 or -1 to 1, etc. Fine. But these activation functions, they are useful in learning high dimensional data or the complex data such as audio, video, and images. That's where the activation functions come into pictures. Now, when you take the activation functions, we have different types of activation functions. We have identity function or the linear function, binary step function, bipolar step function, sigmoid function or logistic function, bipolar sigmoid function, then ramp function, tanh function, ReLU function, and softmax function. So here, coming to this, the first three, they are used for whenever we are working with the linear problems. So these are used with the linear functions, whereas the other activation functions, they are for the non-linear functions. Fine. So we'll take up the different type of function. The first function is the identity function or the linear function. The value of f of x increases or proportionally with the value of x. This function is useful when we do not want to apply any threshold. Then the output value ranges between what? Minus infinity to plus infinity. So you people are familiar. So this is what is the identity function or the linear function. That is f of x is equal to x for all of x value. The second one, it is called as the binary step function. Fine. So it tells that f of x equals to, it gives the output 1 if this f of x value is greater than or equal to the threshold value, or 0 if f of x value is less than what? That is the threshold value. So the output is always a binary value, or that is 0 or 1, based on the threshold value, that is theta. So if f of x is greater than or equal to theta, outputs 1, or else it outputs 0. So this is how actually the graph or the plot of this binary step function look like. This is either 1 or 0. Now coming to the bipolar step function, instead of 1 or 0, it is 1 or -1. So this is also called as signum function. Right? So this is also called a signum function. If f of x value is greater than or equal to theta, it returns 1, else it returns -1. So it is also, a value is bipolar here. It is not binary. So it is +1 or -1 based on the threshold value. So this is how the graph looks like here. But whereas the previous one, that is binary, it is from year to year because it is +1 or 0, whereas this is with the -1. Going to the next one, whatever we are going to look into these activation functions hereafter, they are all used with the non-linear functions. So we have the first one, the sigmoidal function or the logistic function. This is something like the S-shaped curve. You can see the graph here. The formula we'll be using is sigma of x equals to, or f of x equals to 1 divided by 1 plus e of e to the power of -x. So this is widely used non-linear activation function which produces a shaped curve, and the output value are in the range of 0 to 1. Fine. Next, we have the bipolar sigmoid function, where it is represented as sigma of x or f of x equals to 1 minus e to the power of -x divided by 1 plus e to the power of -x. This is how the graph looks like. The output values are between -1 and +1. We have the ramp function. So this is what the output it is going to return. When f of x is, it is going to return 1 if x value is greater than 1. If this is between 0 less than or equal to x, between 1, then it is the x value. It is 0 when s is less than 0. Whenever the value is between 0 and 1, it is always the value that gives the x value. If the x value is greater than 1, then it returns 1. If x value is less than 0, then it returns 0. So this function is called as ramp function. Finally, we have the next one, that is tanh, which is called as hyperbolic tangent function. This is the formula we'll be using for this activation function. So the tanh function is a scaled version of the sigmoid function, which is also a non-linear. The output value ranges between -1 and +1. Next, we have ReLU. it is called as rectified linear unit function. So this is the one that we are going to use. So r of x equals to max of 0 comma x. So if it is x is greater than or equal to 0, then we are going to take the value of x as it is, not like 1 or 0. If x is less than 0, then we are going to take the 0 value. The activation function is typically a function generally used in deep learning neural network models in the hidden layers. So this is where the ReLU comes, and this is the mostly used activation function in the deep learning whenever we are having what? Hidden layers. We can have more than one hidden layers in the artificial neural network. So the hidden layers, it is always works well whenever we use what? The activation function, that is your ReLU function, rectified linear unit function. Then this function outputs a value 0 for a negative input value and works like the linear function of the input values are positive. Next, we have the softmax function. So this is the formula we will be using. This is a nonlinear function used where now is in the output layer that can have multiple classes. So if it is a binary class problem, we have only two classes. If we have multiple classes, we can have more than two classes. So whenever we have more than two classes, that is multi-class problems, then for the output layer, it is always better to use this softmax function. Even the value ranges between what? That is 0 and 1. So these are the different types of activation functions that are available. Along with that, there are some more activation functions, but some activation functions, they are used for along with the linear, and some activation functions are used along with the non-linear functions.